Y'all should be ready to go. Questions? A bunch of you knuckleheads still hadn't turned in A and B. Bunch of you guys. I need A and B turned in. C and D should have been turned in. Big test coming up. Maybe something today. Questions over anything before I have some for you? Anything? Yes, sir. Whatever you want. I don't know if I can or not, but we'll try. Okay, so if you haven't done this yet, let's look at 14 on, you said on C, right? So 8, 9, 10, 11, 12, 13, 14. Oh, that's the challenge one. Ooh. Do we want to jump into that one first, or is there something before that? Go ahead and do this one. All right. Ooh, 3. That's probably what made it a challenge, huh? Is a 3? Okay. So this says challenge. Anytime it's a challenge, guys, what that's doing probably, my guess is, if you can do something like this, you probably can do most of them. You'll follow kind of along with that. And also challenge, I don't think you'd see one that difficult. Just kind of, I didn't know that there was any of these on there. I don't ever look at this stuff. I always go in this stuff blind, Neil. So f of x is log base 2 of this minus log base 2 of that. What all values of f of x is greater than 3? And we're used to seeing a 0 over there. Or we're used to seeing f of x and g of x, and f of x is greater than g of x, or that kind of stuff. But this particular one, we got f of x is equal to that, and we want f of x to be greater than 3. And so the first thing I'm going to do, I'm going to go ahead and make this log base 2 of x squared plus 10x plus 24 over 2x minus 1. If I change that to equals now, am I okay? Bless. Because our first goal is to find out when it's equal to 0. That's our first goal. Find out when it's equal to 0. That way you can find those, I don't know what you call those, the big points, or the points where it's equal to 0. And then if it's 0 here and 0 here, it's either above or below between them. So again, I just focus on when it's equal to 3 first. I would do the loopity thing here. 2 to this, 2 to 3 is that thing. So I got x squared. I'm probably going to run out of room. X squared plus 10x plus 24. 2x, whoa, minus 1 is equal to 8. That's what I mean by the loopy thing, right? Y'all should get pretty comfortable with doing that. Multiply both sides by 2x minus 1. And so now this will be 16x minus 8. And move the 16 to the other. Anytime you have a quadratic, it's got to be equal to 0. You cannot solve a quadratic without it being equal to 0. You can't solve anything. Linear, you don't have to be 0, but everything else has to be 0. So I'll move the 16 over there. That'll be a negative 6. And move the 8 over there. That's 32, 24, 25, 26, 27, 28, 29, 30, 31. Yeah. Sorry. I've used my fingers my whole life. So I finally have x squared minus 6x plus 32 equals 0. And I got to find out when that bad boy is equal to 0. Oh, 8 and 2? No, 8 and 4? No, it doesn't factor. Cuss. There once was a bad boy who could or could not decide to go to a radical party. He was a square dude, so he missed out on 4 awesome chicks. Uh-oh, that's an imaginary? I'm going to stop right there. If it's imaginary, there's no reason for it to be 0. That means basically we have a quadratic that's either always above or, well, it's always above because it opens up. Y'all follow what I'm saying? Because it opens up, there's no way it can ever be below that because it opens up. So we probably have we have a quadratic that's above the x-axis. Okay with that? So basically this whole thing's either always well, no, I guess it's always got to be a positive. No matter what I plug in here, I'm going to be a positive. 0, 1, 2, 3, 4. Am I thinking correctly? Good? Because it's never 0. I can't draw a number line and ever have it 0. If I have, that quadratic does something like that. I don't know what it does, but it's above the x-axis. So I think the only thing we're worried about is trying to take the log of a negative. I think the only thing we're concerned about is taking the log of a negative. In other words, there is no way that 2x minus 1 has to be greater than 0, because there's no way you can take the log of a negative. So if you add 1 and divide by 2, x has to be greater than 1/2. It has to be. And then over here, does that factor? 6 and 4. X plus 6, x plus 4. X equals -6 and -4. So x has to be greater than -6. Less than? Greater than. I think greater than. But we already know it has to be greater than 1/2. So it has to be greater than -6, but it can't be greater than -6 because it's got to be greater than 1/2. So I think the answer to this one is x is greater than 1/2. I think it's 1/2 to infinity. I think. I don't know. But that's what I'm going with. And if I was at home trying to figure out this problem, and you guys got to that point, I would go to my little calculator and I would graph this stupid thing right here. And I would graph that right there. And see when this graph is bigger than that graph. And it better be starting at 1/2. Y'all follow what I'm saying? That's what I would do. Do I have a calculator on this thing? Yeah. Just to kind of show you guys. Because I'm going to check it that way because I don't know if I'm right or not. Is that thing opening? Gosh, I need to open that right when I get to school. I get here early enough. It ought to be open by the time the class starts. Math. Is that on math or is it on number? There it is, log base. Log base 2, x squared, plus 10x plus 24, minus log base 2, math, log base 2, 2x minus 1. Okay. 3. Zoom 6, because there's no telling what my window looks like. Uh-oh. Oh. Yeah. I think I'm good. That thing looks like it's always above 3. So it's above 3 for everything, but this graph is not defined for everything. So my guess is I have a vertical asymptote at 1/2. I feel pretty good about that answer now. That challenge wasn't as much of a challenge as the others, because when it got to that imaginary, I'm going to stop. I mean, there's no reason to find imaginary zeros for this. Zoom out. Yeah, it never goes below it. So it's always above it. It's always above it. So this is always above 3. So it should be from negative infinity to infinity. However, this thing's not defined from negative infinity to infinity, because this over here has to be greater than -6 and greater than -4. And this over here has to be greater than 1/2. And so because this over here has to be greater than 1/2, I don't care about that being greater than -6 or -4, because we know we got to be greater than 1/2. Cool. I would expect you guys to, I don't want to say struggle, but question yourself a lot during that question. Right? Like, oh my gosh, what am I doing? I don't know what to do. Probably give up, stop. I get it. I understand. It's okay. That's why you come to school saying, I don't know how to do this question. Or email, man, I have no idea how to do this question. Can you help me? And a lot of times what I'll say is just ask it tomorrow in class, because most time if you have that question, everybody's got that question, and I'm better off going over it today in class than trying to email it back 28 times. Yay? If it's the day before the test, I typically make you a quick YouTube video and I'll send it to you, because that's the best way to teach it than trying to just write it or do something like that. I don't know if that's happened to you yet or not, but I know my stats kids, that's what they do. And what's really nice is after I've done it, I can send it to somebody else if they need it. Okay. Yippee, yippee, yo. Happy, happy, joy, joy. Any other questions over these? Because I got some for you. Yes, ma'am. Say again? Rest of the answers? I don't know what they are. I don't. That's kind of why I graph them. I don't know. I just graph them and figure it out. You want me to, you got one that you got a question about? Well, no, do you want to verify that you got them? Yeah. Oh. These are blank, except for that one. Chat GPT. How do I do this question? I don't know. I got answers somewhere. I don't know where they are. That's what hit me. I can. I can do them all. I think. If I can do that one, which one do you want? Is D the back page? Yeah. Number 7? See, everybody's asking. All right. Look at this one. Okay. These are the ones, guys, like I told you, that number, they mentioned, right, that number 4 on the test that you guys are going to take in May, right? It's going to have something like this. We don't know exactly what it is, but we know we're going to have to reduce or simplify or do something with this. And all these deal with e. So my guess is it's going to be something like that. I got 6e to the 4x minus e, and I'm solving that for p of x is equal to 2e. So basically I'm replacing that that p of x with 2e. And this is 6e to the 4x minus e. Ooh. I probably are going to move this 2e over here. I don't know. X is up here, so I don't know if that's right, wrong, or indifference. Go ahead. Putting it over here? Yeah. I mean, I don't think it matters. That's why I say I think that's what makes these hard is you might do it this way and somebody else might do it that way. I just have a bad habit. I say bad habit. I don't know what. I have a habit of setting everything equal to 0. But there's a good chance that if I move that over here, I'm going to move it back over here. In fact, I know I'm going to. But if I move that over here, that's a negative 3e in 0 over here. And if I move this over here, this is a positive 3e either way. What I noticed is as soon as I move it over there, I got a 3 and a 6. I'm getting ready to factor something out, and I'm getting ready to divide something by something to get rid of my constants or my one of them. All right, so I'm going to put it back over here because I didn't know that, right? So I'm going to say 0 equals 6e to the 4x minus 3e. And now I can divide everything by 3 if I want to. And if I divide this by 3, that's 0. And if I divide this by 3, that's 6. And if I divide that by 3, that's 1. And so there's nothing wrong with that. You don't have to do that. But again, anytime we can make something bigger or smaller, we try to make it smaller. So this is now a 2, and this is now a 1. And now I'm trying to get x by itself. And if I'm trying to get x by itself, I don't want this over here with it. So now I'll move it back over here. So I should have moved it over here to begin with. But either way, it's okay. So now I have e equals 6. Oh, this is hard. Yep. Oh, thank you. Dang it, cuss. I would have done this whole thing and got that wrong. Whoop. Thank you. That's what I get for skipping steps here. And also, there's not a whole lot of room. You have more room than this, or this is what you have? Yeah, that's tight. Sorry. So I got an E, and I got a 2E. I'm going to just take the natural log of both sides. I don't know if that's right, wrong, or indifference, but I'm going to take the natural log of both sides. Okay. This is tricky. These are not easy. These are not easy. This is nice because the natural log of E is 1. But this over here, that's tricky. You can't leave it like that. You're going to have to, I'm going to make this a 1. Then what I got to do here is I got to make this the natural log of 2 plus, how about 4x natural log of E. I know that's really low for some of you guys. Let me do this. Let me just so you make sure you guys can see this. Clear, blank white screen. Turn this on. Oh, there you were. Okay, so this is what I had. I had E equals 2e to the 4x. Okay, this is what I had. You have got to get this x down on front, and the only way to do that is either take the log of both, to take the log of both sides. I don't want to take the log of both sides because I have e's, so I'm going to take natural log of both sides just to clean things up. Yep.
Wouldn't you just divide the other e by 2? You have 1/2 e, then take the natural log of both sides, and you have natural log of 1/2 e is equal to 4x, then you just divide it by 4.
You definitely can do that. Go ahead. I'll keep going. Okay, you want to go? We'll go this way, and then I'll show you the way I was going to go about this. Okay, so now we'll take the natural log of both sides. Natural log of 1/2 e. They're not going to like that as part of the answer. They're not going to like that as part of the answer because that can be simplified. Okay, they will not like that as part of the answer. That can be simple. Is equal to the natural log of e to the 4x, which kicks that 4x out front. But they will not like natural log of 1/2 e. That can be simplified because you can make that the natural log of 1/2 plus the natural log of e. because this is 1/2 times e. And if you're taking the natural log of something times something, you can split that up into the natural log of something plus the natural log of something. Whew, that's tough to know. That's tough to see. That's tough to see. And then over here, I have the 4x natural log of e, which that one's just 1, so I don't need to worry about that. And then I'll divide by 4. But what's this natural log of e? 1. So I have the natural log of 1/2 plus the 1 all over 4x. And I don't think they'll like the 1/2, but I don't know if that matters. I was going to end up with a natural log of 2 plus 1. Thank you. I knew it wouldn't. I knew it had to be something different. 1 minus the natural log of 2 over 4. Because the minus the natural log of 2 could put that negative up top and flip the exponent. Anyway. I bet that's what they would like as their answer. Did that help, Ev? What do you used to have a confused look? You don't know where you have a confused look. They're not easy. They are not easy, guys. I'm telling you, they are not. I told you at some point they got to figure out the difference between a 5 and a 4 and a 3 and a 2 and a 1 somehow. So they're not going to make everything easy. So there will be some hard stuff on there for sure. There should be some easy stuff on there too. At least I hope. I hope there's a lot of easy stuff for you. And some of you, this may not be hard. I don't know. I got to go back here. Click. Yeah, because I was getting ready to have to move the natural log of 2 over and make it 1 minus the natural log of 2. And then this is the one, and then divide that by the 4. But this is hard to recognize. Some of you might want to put that 4x out front here. You can't do that because only the e is to the 4x, not the 2. So that's why you have to split this up into 2 separate ones, because that's 2 times e to the 4x. And you guys know that 2 times e to the 4x, I can split that up into the natural log of 2 and the natural log of e to the 4x. And then I can put the 4x in front. There's a lot of catches on that. Talk to me.
Did you work the problem out the way that you were going to do?
Yeah. So are you okay to this point?
Yeah.
Okay. So then right here, I got to move the natural log of 2 to this side. So I got 1 minus the natural log of 2 is equal to 4x, and this is just 1. And then I'll just divide it by 4. And to me, that's a little bit cleaner than the other one, but either one of them are going to be acceptable. But at any time, if they see a natural log of e, they know you didn't simplify it. Just like if you saw the natural log of 2, you didn't simplify it. And so that's why when having the, whatever we had over here, whoops, sorry, no, gummit, here, I can't divide that by 4 because that's not simplified. I mean, it's right, it's not simplified. Just not simplified. It's like leaving the square root of 8. That's right, it's just not simplified. So if you're worried about getting it wrong, you're better off not simplifying it than getting it wrong. However, their instructions say simplify it. And so if their instructions say simplify it, then it's wrong because it's not simplified. So I don't know what the rubric's going to give you point-wise. I don't think there's such thing as less points for leaving it like this and not simplifying it than getting it wrong, but I don't know. I would think that if you could get it to here and just divide that by 4, you're going to get some points for sure. Because you know a lot of stuff, it's just you didn't finish it. And that's why either one of these answers are okay. Click. Evelyn, did that not help you? You still look worried, huh?
No, I think I can make it.
Okay. Any of these others I need to try to work on? Anybody? Anybody? It's your time now. We got a pretty quick lesson today. That's why we have time for a quiz, unless you keep asking questions. Yes, ma'am. I can. You'll know this by now, surely. Huh? I can work them all. You can? Oh, you probably can. Which one did you say? I'm sorry. 6? 6. So I got E. Ooh. Equals 3e to the 4x minus 5e. I think this works almost exactly like this one. So we can move the 5e over here and make it 6e. In fact, I don't know what the difference is other than we got a bigger number. Yeah, I think this works exactly the same way. So I'm going to move this 5e over here and get 6. Divide both sides by 3. Take the natural log of both sides. Can I go ahead and kick that 4x out front? It's supposed to be natural log of e to the 4x, but you can kick that 4x out front. That's one of the rules. And so the natural log of e is 1, and I'm perfectly okay with you doing that. Now divide both sides by 4, but you got the same issue. You didn't simplify this. You didn't simplify that. You need to make that the log of 2 plus the log of e. Because 2e, this is times right here, you can split that up into 2 logs. And so this should be the natural log of 2 plus the natural log of e. I apologize for shortening all this stuff up. I just don't have a lot of room. And then that's equal to 4x. And so you should get the natural log of 2 plus 1 all over 4. I don't think there'll be any other answer on that. I mean, I don't think that simplifies anymore. This one doesn't. Did this one? No. One of these might. Nah. Did you get it right? No? I understand. Oh, you know you're supposed to do that page? Knucklehead. As part of 13 or 13B. A and B is 13A, B, C and D are 13B. Y'all follow what I'm saying, right? When you're uploading, get this stuff uploaded. I mean, it's 3 points, but those 3 points add up after a while, right? I was looking at some of you guys' assignments last night that had them uploaded. There was not very many. You guys are not holding up your end of the deal. What else? Any page, anything. Some of y'all said this was hard. Let me show you how to do it. Yes, ma'am. Because natural log of e is 1. right? Let me go here. That's just the old. It's like that's 1. So that's base E, or natural log is log base E. That has to be 1. Because E to what is, right? Fine. I know it's a while. It's weird because you're just not used to seeing that. Yes, ma'am. May I? I may. Sure. Sure. Could you please show me how to do number? I'm gonna get it right one of these days. Which number? I'm sorry, hon. 11 on C. 8, 9, 10, 11. Okay. I out of all the questions, the last page, I think those are difficult, but once you've seen several of those, these are difficult. Finding inverses, I don't think are too difficult. If you think those are difficult, you need to practice more. Those you should be getting right fairly easily. These take practice, right? I got log. I'm got x squared plus 3x minus 5. I'm going to go ahead and put that over 7x plus 16. And I want that to be greater than 0. I'm going to go ahead and say it's equal to 0. Okay? And then this is base 10. So I'm going to do my loopy thing because I don't know how to solve for anything that, if I got log on one side, that's what you have to do. If you got log on one side, you basically have to rewrite it exponentially. So 10 to the 0 is equal to the x squared plus the 3x minus the 5, and I'm going to multiply both sides by the 7x plus 16. Okay, did I do too much without you following that? 10 to 0 is 1. 1 equals that over 7x plus 16. Multiply both sides by 7x plus 16. Now I got to move the 7x over there, which is negative 4, and I got to move the 16 over there, which is negative 21. So I've got 0 equals x squared minus 4x minus 21. It's my math check, everybody. Now we hope it factors. It does. So we'll do an x minus a 7 and an x plus the 4. And I'm going to go my little number line. And I'm going to put a negative 4 and a positive 7. I apologize. My back's to a lot of you. Uh-oh. Where'd I miss? Gosh! Cuss! See? First mistake this year. I got so excited. Do all the hard stuff and can't even freaking factor right. Okay, now we're good. And so I'll test a value over here at like negative 4. And you can test it here, 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 you can test it up here. It doesn't matter where you test it because they're all the same thing. They're all the same thing. So it doesn't matter where you test it. I know a lot of times students go, where am I supposed to test? It doesn't matter. It's all the same thing. Whatever this started off with, I just ended up with this. I made it a lot simpler. So I would probably test it here. Negative 4. That's negative. That's negative. Negative times a negative is a positive. And I want it greater than 0. So I need all those values over here, except I'm sure there's going to be a little catch. So my guess is if all those are positive, I'm betting all these are negative, and I'm betting all those are positive because it's a parabola. And you guys have learned that a parabola has to open up, and if it has one x-intercept, it's got to have another x-intercept, and I happen to know where it is. There's negative 3 and positive 7, so it's got to do that. But you can test points, you can do whatever. 0, that's negative, that's positive, negative times positive, negative, yeah, it's negative. Okay, you should, after doing these for several times, you'll start seeing that a lot easier. But I do have an issue because we know right here, 7x plus 16 has to be greater than 0. You got to know that because you can't take the log of a negative. And so if I move the negative 16 over there and I divide by 7, I got negative, 16 sevenths. Negative 16 sevenths, which is like 2 point something. Negative 2 point something. See, that's on this side of it, right? So I can't go from negative 3 up because I can't be negative 3. Because if I'm negative 3, that's negative, and that's bad. You can't take the log of a negative. And because that's negative 3 and this is negative 2 point something, that's probably where I'm going to start. But I probably need to check this also. So I'm running out of room. I also know that x squared plus 3x minus 5 has to be greater than 0. Yuck! Stupid quadratic formula crap. Negative b plus or minus b squared minus 4ac all over 2a's. That was a 5, wasn't it? Yep. Yep, that's 29. Square root of 29 is like 4 point something. Oh, who wants in? Somebody wants in. So I got negative 4 plus and minus 4 point something over 2. Man, I can't believe you got to do all this stuff without a calculator. Negative 2 plus, or negative 4 plus 4 point something is like point something. And point something divided by 2 is positive. Yeah, we're okay. I don't think I need to test that because it's positive. Negative 4, that's negative 8 point something. Negative 8 point something divided by 4 is negative 4 point something. And negative 4 point something's over here, so I'm not worried about that either. Because I already know I've got to start at negative 2 point something. Hit me. Right. Oh, it can't be 0, 1? Why not?
Because 1 squared plus 3 times 1 is 4. But you wouldn't even need to do that because that's all negative. In between negative 3 and 7. Anyway, you look at what's greater than 0.
Right. Oh. Like 6? 6 won't work?
No, because that's a negative outcome.
Why is 6 a negative?
Because plug that in for the equation over there. So 6 minus 7 is negative 1. That's positive.
Huh? Where? What?
Above the line.
Oh, all this is negative.
Yeah. And you're looking for greater than 0.
Oh. See, I'm doing a lot of this work and I'm still even have, I see what you're saying now. I'm sorry. I was going to test, right? I'm looking for positives. I'm being a complete idiot here, wasn't thinking. I'm looking for positives. And so positives go from negative infinity to negative 3. Well, I can't go from negative infinity to negative 3 because this tells me x has to be greater than negative 2 point something. So negative 2 point something's right there, but that's where this stupid thing's negative, so I don't care. That's where I have to start to be bigger than 0. So I have to start at 7 and go to infinity. It can't be equal to 7 because you can't take the log of 0. And I'm okay right here because none of that's ever negative. That far right. That far right. And what you can do, guys, is test 7. Test 7. 7 squared is 49. 49 plus 21 is a pretty big number. Minus 5, that's a pretty big number. And it's just going to keep getting bigger and keep getting bigger and keep getting bigger, so I'm okay. I didn't need to do this quadratic formula stuff. I didn't need to. You can. I mean, it's not wrong, but I didn't need to because this is where I have to start, but I can't start there because it's negative. So this is where I have to start. You still have a squinchy face. What's a squinchy face about? Y'all know what squinchy, like when I look at you guys and see, those are squinchy faces. If the middle wasn't negative, yes, yes, I would have to start here at this negative 16/7 because this part over here was all less than that anyway. Yeah. We got to have positives. And most of the time, they're going to have greater than 0. I don't think they're going to have less than 0 because that messes our logs up bad. If that was less than 0, there's no answer to this. Yep. Say that one more time now. The loopy thing. I always do the loopy thing, yes. I'd still do the loopy thing. That is correct. Because you have to rewrite it exponentially. And so to rewrite it exponentially, you have to loopy. Because normally this is 0, and anything to the 0 power is 1. If it's not 0, then you won't be 1. That is correct. Great question. Great question, and I think you guys know, but it's just one of those things that just makes you feel better when you get verified. Elena? Yay? Okay. That didn't sound reassuring. Yes, ma'am. Don't be sorry. Which one? On 14?
Yeah. So when we got that equation, x squared minus 6x plus 32.
Yes.
And we started solving it, and then you said there was an I, so we stopped.
Mm-hmm.
How did you know to pick 1/2? Like, how would you know it wouldn't be like 1/4 or something?
That right there. That told me that x has to be greater than 1/2. Because if it's not, I mean, that's one, because you add 1 divided by 2, right? That's how I knew. Because this one has a vertical asymptote at 1/2. This one has a vertical asymptote. It may, I don't know where. But it didn't matter because they were both bigger than 1/2. So 1/2 is the absolute smallest thing it could be. You're welcome. Man, you guys are good. You got to be doing your stuff. You got to practice these. Practice, practice, practice. Luckily, you know, anything in the grand scheme of things, it's like one question, maybe 2 questions on a test. But 1 or 2 can make or break you from an A or B, or C or D. Or it can't break you from an F to an F because an F is an F. Don't be getting Fs. Anything else that you guys need help with? Any other problem that I need to show you guys? Yes.
Number 2 on D.
2 on D. Uh-oh, I didn't quite bring it down long enough. All right. E to the 2 is equal to e to the x to the 1/2 e to the 3. Multiply both sides by e to the 3. I don't know. I don't like fractions. So multiply both sides by e to the 3. If I multiply this side by e to the 3, it goes away. Multiply this side by e to the 3, I'm going to get e to the 5. You got to add exponents. So I got e to the 5 equals e. I'm going to go ahead and do a power to a power. Because power to power, you multiply. And I got e to something is equal to e to the something Basically, those somethings have to be equal, or you take the natural log of both sides. Whatever you want to do. Officially, you're taking the natural log of both sides. That's officially what you're doing. You're taking the natural log of this side and you're kicking that 5 out front, and you're taking the natural log of this and you're kicking that 1/2 out front, and then you're just dropping the natural log of e's because that's 1. That's not mathematically correct, but it's okay because that's what you're doing. So 5 is equal to 1/2 x, multiply both sides by 2 to get x by itself, so x is equal to 10. You can go over here and check that. E to the 10 to the 1/2 is e to the 5. E to the 5 over e to the 3 is e to the 2, and that's e to the 2. So x has to be 10. You should always check. You have to check when you got log written up there. If you got the word log up there, you got to check. Because you can get those extraneous answers. Good, Lake? Cool. Anything else, ladies and gentlemen, as y'all are looking that over? Yes, ma'am. I don't like that word always, but talk to me one more time about what you just asked before I say yes or no. If you have an E on one side and E, again, mathematically, that is not correct. Canceling those E's out, that's not mathematically correct. That's what you're doing, but it's not mathematically correct. If you want to really show the grader that you know what you're doing, take the natural log of both sides. This is mathematically correct. You're taking the natural log of both sides. If you take the natural log of one side, you have to take the natural log of both sides. So you're not really just dropping those E's. That's not really, and now you can kick that number out front because that's what the rules of exponents say for natural logs. So now you have 5 natural log of E is equal to 1/2 natural log of E, and you know that natural log of E is 1. And so now you have 1, and now you have 1, and now you have, whoops, I forgot the X, sorry. And now you have 5 is equal to 1/2 X. Mathematically, that's the correct way. I would be okay with you canceling those out because that's common sense way, right? There's a difference with a little bit between mathematical and common sense. But mathematically, if this is E to something and this is E to something, and one of those somethings has an X, then those somethings have to be equal. They have to be. Because if this, it's got an equal sign right here. Well, yeah, there it is. If this side equals this side, and this is E to something, this is E to something, those somethings have to be equal. Now, if it was 2 equals 5, and those somethings aren't the same. So that's when you'd have to take the log or the natural log of both sides. But because they're the same base, you can just drop those bases. Does that answer your question? I won't. By doing this over here, is that what you're asking? Yeah, I won't. I don't think so. I don't know. I would hate if somebody wanted to argue that. I'd argue with them. Because I tell them, I said, you don't understand. My kids are freaking smart. And they know that. So they're just doing something to save themselves some work. Shut up and let them do it. No, I don't know. I won't. So that's all you care about right now. Fair? I'll ask Miss Mim. She actually grades this. So I will ask her what she would do. She AP pre-cal grades, and then there's a teacher at West at AP pre-cal grades. I AP stat grade. They asked me to do this one. I didn't want to do this one. I didn't want to do 2. I mean, how much fun is it to go somewhere and sit down for 8 hours and grade? It's not. They don't want you to do it fast. They want you to do it right. Oh, I got a star. Whatever. Yeah. It's really interesting how they do that. Not that it matters to you guys. You have a computer in front of you, so you guys will take it and write it on paper, right? And there's some knucklehead gets to scan all that stuff, and so they scan it. So when I'm grading that paper, I only have to grade one question, and so I grade one. So I'm in front of that computer and I'm just reading. I decide what they get, and I hit the points and I hit go, and the next one comes up, right? And there's 240,000 papers. I don't have to grade all 240,000 of them. There's 160 of us in there. Anyway, you don't care. But at some point, a test comes up that's already been graded. And you don't know what it is. And you grade it, and you grade it, and you better grade it the way it's been graded before. And if it's not, they make you go to class again. Because they want consistency. I mean, you guys that makes sense, right? So they want to make sure. So every once in a while, they'll throw another paper in that's already been graded by somebody else, not by another grader, but by somebody. So you have table leader, you have the question leader, they're in charge of the whole question. Then you got a table leader, and then you got us. And so it's been graded by the big person. And everybody gets it at some point. I never had to go back to class. I always graded it right. Some people do. I'm not going to sit at home and do it. I'm going to go something. They send me to Tampa, Florida. I'm good. I'll go to Tampa, Florida. Shoot, yeah. They pay me. Better than sitting in Bentonville, Arkansas, my house. Click. Ooh, squirrel. Ooh, what's on YouTube? Click. Okay. Everybody else good? We'll find out. After we do 214. All right, ladies and gentlemen, we got 214. I got 215, and then we're going to review, and we're going to test. And on review day, I'm going to give you your old tests back so we can look over those. Okay? So we got a lot of stuff to do. What's up? What now? Not yet. Can't hurt your grades. But thank you for reminding me. Yep. No, I got that saved for my little. All right. Here we go, ladies and gentlemen. 14 and 15 are very, very similar. And so these are the ones that you guys have done in previous units or previous questions. The last section or the last two sections are always this regression stuff with your calculator. Okay, unit 1 was, unit 2 is, and unit 3 is. So they're all like the word problems. They deal with that. Okay, so this is setting you up for 15. All right, so here we go. Logarithmic function context and data modeling, or data modeling, however you want to say it. So I'm looking at some kind of graph. I got a church size and I got the average salary. Whatever, it's probably going to talk to me a little bit more. The average salary for church pastor across the U.S. increases as the size of church increases. The graph above shows the average pastor salaries for various church sizes. Good gracious. 4,000 people? Okay, whatever. We can clearly see a pattern in the data, but the models have used previously are not appropriate for this. This is not an exponential pattern. It is not a linear pattern. It's not quadratic. It's not cubic. It's not a polynomial. Of course, we don't do polynomials. We pretty much do linear, quadratic, and exponentials. And this is neither one of those three. This is logarithmic because it's kind of starting this way and going off. Exponentials go up or go down. They don't do that. Okay? We can clearly see a pattern in data, but the models we use previously are not appropriate. They grow up. This displays a large rate of change initially, but as the church size increases, we can see the rate of change gradually decreases. The data above appears to be logarithmic. Just as we have seen other types of functions, linear, quadratic, and exponential, Many real-world scenarios, I know it's scenarios, follow a logarithmic pattern. Outside the salary data on the graph above, logarithmic patterns are found in the way we measure earthquakes, sound, acidity, and many other contexts. As a result, we need to create logarithmic models for these types of data. Okay? Again, we're kind of just soaking all this stuff up. Logarithmic function models. For a given set of data, if the input-output values appear to change proportionally over equal length output value intervals, then the logarithmic model is appropriate. What's nice is, guys, most of the time they're going to tell you what this graph is. Most of the time they're going to tell you. But you're going to, if not, you're going to have a choice of 4 things right now. Linear, which you ain't going to see in this class. Quadratic, you might see. Exponential, or logarithmic. And then you'll have a sinusoidal one in chapter 3. For the given set, so the logarithmic function has the model of y equals a plus b ln x, so natural log, or y equals a plus b log x, where a and b are constants. There's some values. Of course, b can't be 0, because if b was 0, it would no longer be logarithmic. It would be a constant, because you have 0 times everything. So they put these things in there just to make a duh statement. Here I have 2 points, a whopping 2 points. Now, I think you guys know out of 2 points, that could be linear, it could be quadratic, it could be exponential, it could be anything out of 2 points, because 2 points, I can connect that however I want to. Selected values are a logarithmic function. Oh, now I know it's logarithmic. They're given by that table where L of x is equal to a plus b ln of x. So be careful about that and make sure you recognize if it's the natural log or log. Most of the time they're going to put natural log. Why? Because we're lazy. And log is 3 letters and ln is only 2. Use the given data to write 2 equations to find the values for the constants a and b. Well, guys, this should not be difficult at all. And it's the same question you guys had to do on last test. Write 2 equations. Well, I already know I have ln. Can I change that to y? Y equals a plus b ln x, right? And what did they give me? Well, they gave me an x and they gave me an ln of x. So I just got to plug and chug. I'm going to plug a 3 right here. And if I use the 3, I've got to use the 2. And there is absolutely no way for me to find a and b like this. However, I got another equation. And that other equation is going to be 7 equals a plus b ln 5. And that's what they wanted me to do. Use the given data to write 2 equations. I wrote 3. However, this one doesn't matter. Can be used to find the values for the constants a and b. And this can find the a and b because we have what? 2 unknowns, a and b. And if you have 2 unknowns with 2 equations, you can find the unknowns. If you have 2 equations, 2 unknowns, you can find the unknowns. I'm supposed to find a and b now. This might be, no, this is the hardest thing you can do. I'm going to line those 2 up. I don't like substitution. I'm going to line them up. 7 equals a plus b ln 5. And then, I think it was that blue. 3 equals a plus b ln 2. And I'm supposed to find a or b. And the easiest way to do this is to subtract one of these. Because if I combine them right now, I'm not going to get rid of a variable. I want to get rid of a variable. So I'm going to make this a -3. I'm going to make that a -a. And I'm going to make that a -b. And now I'm going to combine these 2 equations. If you guys can think back, when you had 2 equations with 2 unknowns, you solved it graphically, which never was really good because it was kind of hard to find that point sometimes. You could do it substitution. So I could solve this for a and put it in this one. And you can do it that way, that's fine. Or that, I think the other one's called elimination or the addition method or something like that. So I'm using the addition method. You can do it however you want. In this particular way, the a's go away because you have a positive a and a negative a. And I got 7 and a negative 3, and so that's going to give me 4. Let's turn this to red. So I got 4 equals, the a's went away, and now you cannot combine those because they're kind of like unlike terms. So this is going to become b natural log of 5 minus b natural log of 2. What? Because b's are not by themselves, but a's are. Fair enough. That can cover it. Okay, now I got a b natural log of 5 minus b natural log of 2. Factor out a b. Factor out a b. We're trying to solve this for b, so we need b by itself. You can't subtract those. Those are unlike terms. You can't do it. You can't. If it was 3b minus 2b, you could. And I guess you could, but it's going to be nasty. So I'm just going to do 4 is equal to b natural log of 5 minus natural log of 2. And now to solve that for b, we're going to divide both sides by the natural log of 5 minus the natural log of 2. I apologize. I know my back is to 90% of you guys. Natural log of 5 minus the natural log of 2. And without a calculator, there's no way for me to find out what that is. If I got a calculator, I'm going to punch all that stuff up and figure out what it is. But if I got a calculator, I'm not doing it this way. Not. I'm getting ready. I'm going to do it the other way, what I'm getting ready to do. And now you still got to find a. You still got to find a. So plug that in for b. And you got a calculator. You're going to punch all that crap up and subtract it over here, and you're going to get a. And you can do it here or here. Either one of those two to find a. Fair enough? I think they're mostly concerned with finding the two equations. And then basically, do you know how to use your calculator to find the other two? Or to find the two values? You could maybe, just to verify, solve this for a, move the b over here, and graph it, like a is like your y and b is like your x. Move this one on this side, and you have two equations, and graph them and find the point of intersection. Fair enough? Because you can solve them how? Graphically, substitution, or addition. If they don't let you use your calculator, you got to leave it like this, and solving for B or A is now hard. Okay. Next part. Good? Example 2, this table above gives the data of the graph beginning in the notes related to the church size and the average salaries for the pastor in the United States. Use the regression capabilities of your graphing calculator to find a logarithmic function in the model of SPA plus B natural log P, where P represents the church size and S represents the pastor's salary in thousands of dollars. So you're going to go to Mr. TI, or you're going to go to Desmos, whichever one you feel more comfortable with, and you're going to go to Stat Edit. And I bet I got stuff in there. I do. So I'm going to go to Stat Plus, and I'm going to clear all my lists. Clear all my lists. 4. Enter. Now I got Stat Edit. Beautiful. And I'm going to cheat. Not cheat real bad, but maybe. Yep. Give me the first number.
75. 120. 250. 300. 450. 650. 900. 1500.
15.
1500. 2500. 5000.
cheat, use your resources, however you say it.
42, 58, 70, 79, 88, 95, 110, 125, 138, 175.
Yay. Happy, happy, joy, joy. Got to get that data in there somehow in order to find the equation line. Stat, calc, regression. L-I-N. It ain't that one. That's linear regression. That's different than the one that says LN regression. Is there even a log regression? I don't think there is. Nope. It's always going to be natural log, I'm guessing. Enter. X list comes from L1. Y list comes from L2. If you didn't put it in L1 and L2, make sure you put it to where you put it. This is second L1. Those are blue down here. So second L1, L2, if you put it somewhere else. I like to always do everything in L1. Frequency. Ooh, that should not be there. Frequency should be just blank. Store it. That's where you do the alpha trace, because you need to put that in Y1. Why? I don't know if I need to or not, but I might as well. Don't try to copy and paste. Don't do anything. Get it in Y1. Let the calculator do the work for you. Calculate. Boom! How many decimals? 3. Can you put more than 3? Yes. Can you put less than 3? You can. You're just going to miss it. You're going to miss it. Do they care? Do they care if that's an 8 or a 9? No. They don't care if that's 8 or 9. You are just better off writing 4 or 5 than worrying about 3. They will not. What graders will do, if you write 4 or 5, they're going to go until 3. And they're going to read it. So they don't care if you put 16, you can put 16. They're going to put a piece of paper over it until they get to 3. And make sure those 3 are the same as yours 3. Now that can be an 8 or a 9. This cannot be a 2 or a 3. That one has to be a 2. What the heck just happened? And I got too close to 0. Can I just do that? Yep. Where'd that go? There. Y'all okay? Y'all good? So we got the A and we got the B. This is a little trick for your calculators that a lot of people don't know. That 3 went up there. Crap, I don't want that. Second entry will bring up the last thing your calculator did. And so when I hit enter, it puts it right back up there rather than have to go through the whole stupid thing again. So here's your A value, here's your B value. Click. Use the regression capabilities, right, to write the equation. Now, they don't want A equals, they don't want B equals, they want S of P equals, now put A plus, now put B, and then put natural log P. Okay? Some of you knuckleheads on test switch things and you start doing X's and Y's. Don't do that. Just do what they ask you to do. They won't count it wrong, but just don't do that. Using the model found in Part A, what is the predicted annual salary for a pastor whose church size is 500? So I've got to go to my little calculator. Where'd it go? Here it is. You can clear that now if you want to. It's now, luckily, guys, I put it here in Y1. Whoops, I still got Y2. Let's get that bad boy out of there. Okay, luckily I got it in Y1. Now the easiest way, get out of this. The easiest way is go back to your alpha trace and just do Y1 and open up a parentheses. And what they want, 500? Boom. Now be careful here. That's what? 94.329. But that's in what? Thousands of dollars. It's in thousands of dollars. So you better put 94,329, and then if you want to put 54 cents, I don't think they're going to, I would put 54 cents. And especially because that last one's a 0. If you're in doubt and the last one's not a 0, I would go ahead and put 0.546 just to be safe. I know it's money. I would put 3 just because you're just predicting. You're predicting. But you need the 94,000. You don't need 94 point. They're going to get you for that because you're not in the context of the question. You're getting the answer, but you're not understanding what it's finding. And it says right there, in thousands of dollars. Okay. Y'all okay with that question? Good. I didn't have to find anything else for that one, luckily. The most common and preferred method to measure sound intensity is decibels. The sound intensity decibels of a sound having intensity I in watts per meters is by this equation. B sub I is equal to A plus B log I. The sound intensity has an intensity of 1 times 10 to the negative 5th watts per meters to 70 decibels. A loud concert has intensity of 1 and corresponds to 120 decibels. Use the given data to write 2 equations that can be used to find the constants A and B sub I. Same type question we did previously. I need 2 equations with 2 unknowns, and my 2 unknowns are A and B. I got to use this one this time. So 70 decibels, 70 equals, what do they want? Uh-oh. Shut up. Come on! What that gun, stupid phone. Oh, they hung up. This phone is locked up. Stupid phone. Took picture. Now I want Apple Pay. I hate this thing. Who's getting checked out? Somebody know? Okay, that boy. There you are. Yo quiero Taco Bell. Okay, he's on his way. North Office. Yep. It was you, Ian. You win. Make sure you go to the North Office. They frown upon that. Okay, 70 equals A plus B log 1 times 10 to the negative 5th. Or 0.12341. 1, 2, 3, 4, 5. I don't care. Whatever you want to put. Scientific notation or non-scientific notation. And now I need the other equation. And the other equation is 120 equals A plus B log 1. That's nice. Because what's the log of 1? 0. Oh, that's nice. Find the values of A and B. Well, I find A really easy because A is 120. Let me move this bad boy up. Log of 1 is 0. 0 times B is 0. A is equal to 120. And if A is equal to 120, then B I put 10 to the negative 5. What?
Is it always log base 10 or like do you just assume
That one is.
that?
Good question. Yeah.
Will it change?
I don't think so.
Okay.
No, they're either going to do base 10 or base E. Ooh, man, this is, what's log 10 to the negative 5th? Negative 5? See, I don't need a calculator for this one. That's negative 5. Because 1 times 10 to the negative 5th is 10 to the negative 5th. And 10 to the negative 5th is 10 to the negative 5th. And log base 10 of 10 to the negative 5th is just negative 5. So this is -5. And so that's B. And so I'm going to move the 120 over here. And the 120, negative 120. And that is like -7. I got to subtract it. -50. Divide by -5. Who keeps wanting in my door? Thank you. Find the values of A and B. That's all I had to do. Find the values of A and B. Yes.
How did you get rid of the B? When you,
B where what?
so like you have 120 equals A plus B times 1.
Log of 1 is 0.
Yeah. So how-
0 times B is 0. You good?
Well, I was just wondering because wouldn't that be B to the 1 to the B? Well,
This is B times log of 1. You can put the B up there, but then you got to pull it back down. I don't, that's just. The human eardrum can burst when sound reaches an intensity of 1 times 10 to the 4th, or 10 to the 4th. According to the model found above, what is the predicted number of decibels required to burst a human eardrum? So now I've already got this. I've got, what did they use? I'm sorry. B sub I. So B of I is equal to A, which is 120, plus B, which is 10, log base 10 of 10 to the 4th. Because 1 times 10 to the 4th is 10 to the 4th. And log 10 to the 4th is 4. And 4 times 10 is 40. And 40 plus 120 is 160. (160 decibels). That's the end, right?
Yes.
How close am I?